So what is an equivalent fraction? What are equivalent fractions? Equivalent fractions are fractions that are equal or have the same value as another fraction. A fraction has an infinite amount of equivalent fractions. So if I told you to find all the equivalent fractions to 3/4, you would sit there and write out all the equivalent fractions of 3/4 for forever, because 3/4 is equal to an infinite amount of other fractions. So let's just find a few equivalent fractions to 3/4. Okay, so you can see I have this model here. This is 3/4. Now I could cut each of these pieces into 2 more pieces, right? And now instead of having 4 pieces, I have 8 pieces. And out of the 8, 1, 2, 3, 4, 5, 6 out of 8 are shaded. So now it is 6/8. But is that the same amount as 3/4? Is there the same amount shaded? Yes. Look, originally 3 out of 4 were shaded. Now there's 6 out of 8, but it's the same amount, right? If this were a candy bar and I gave you 3/4, that is the same thing as if I broke the candy bar into 8 pieces and gave you 6/8. Now, how would I show that? Well, I broke the shaded part, the 3 shaded parts, into 2 pieces each. And I broke all 4 pieces into 2 pieces each, which gave me the 6/8. That's what it means when you multiply the numerator and the denominator by a number. You're breaking them into smaller pieces. Let's do another example. Find another equivalent fraction to 3/4. Well, instead of breaking them into 2, I could have broken each one into 3 equal pieces. All right. Now instead of 3 out of 4, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 11, 10, 11, 12. 9 out of 12. So what I did was I took my fraction, 3/4, and I cut each of the shaded parts into 3 more pieces, and then all 4 pieces into 3 more pieces. And that's how I got 9/12. Okay. Can I find another equivalent fraction to 3/4? Yeah, I can keep going. I can break each one into 4 pieces each, right? So my 3 pieces broken into 4 each, 3 times 4 is 12, and then all 4 pieces broken into 4 pieces each would be 16. So 3/4. I broke each one into 4 more pieces, and now I have 12/16 shaded. 12 pieces out of 16. But is that the same amount as 3/4? It is. It's the same amount. And I can keep doing this. I don't have to break it into 5 pieces. I can break each one into 10 pieces each. Now, I don't really want to draw the lines, so I can just write the 10. I can break each piece into 10 more pieces each. So for 3/4, if I broke the 3 shaded into 10 more pieces each, that would be 10, 20, 30. And if I broke all 4 pieces into 10 more pieces each, that would be 40. So that would be 30 out of 40. Is that the same thing as 3/4? It is. It's the same. Okay? That's why there are infinite equivalent fractions to any fraction. Well, we can also find equivalent fractions by simplifying. We don't have to break them into smaller pieces. We can actually chunk it into larger pieces and still have the same fraction. So let's look at 10/12. What can go into both 10 and 12? Well, they're both divisible by 2, right? We can chunk them into groups of 2, which would give us 5, 6. So with our model, if we chunked it into groups of 2, that would be 1 group, 2, 3, 4, 5, 6. There's 1, 2, 3, 4. We chunked it into larger groups. And you can see that we have 5 out of 6 shaded, which is the same thing as 10/12. So we can also find equivalent fractions by simplifying a fraction. Now, 3/4 we couldn't simplify anymore, so we can't find an equivalent fraction by simplifying because it's already simplified. So for these, we had to cut them into smaller pieces. But here, you have the smaller pieces, and you can actually chunk them into larger pieces to find an equivalent fraction. Okay? Now, we can also use equivalent fractions to find numbers in between fractions. So, for example, let's say I want you to find a fraction in between 2/5 and 3/5. You might say, well, there's no fraction in between 2/5 and 3/5. That's it. Actually, there's infinite fractions in between 2/5 and 3/5. Because what we can do is we can find an equivalent fraction for 2/5 and 3/5, cut them into smaller size pieces, and then you would see that there are other fractions in between. So for example, okay, we can cut the fifths into tenths instead. How do we do that? By cutting each piece into 2 more pieces. So here we have 4/10. 4/10 is the same thing as 2/5. We just cut each piece into 2 more pieces. It's the same amount. For 3/5, we can cut it also into 2 more pieces each, and we would have 6/10. Is there a fraction in between 4/10 and 6/10? Yes, there is. 5/10 is in between 4/10 and 6/10. Therefore, 5/10 is between 2/5 and 3/5 because 4/10 is the same thing as 2/5. 6/10 is the same thing as 3/5. And since 5/10 is in between these two, they're in between the 2/5 and the 3/5. Can we find another fraction in between 2/5 and 3/5? Sure. We can break it into 15ths instead of tenths, right? Break each piece into 3 more pieces. Here you have 6/15ths. Break each piece into 3 more pieces. Here you have 9/15ths. What is between 6/15ths and 9/15ths? Well, we have 7/15ths and we have 8/15ths, right? And that means that these 2 fractions are also in between 2/5 and 3/5. And we can keep going. We can break 2/5 and 3/5 into 50 pieces each, right? Multiply it by 10/10, breaking each piece into 10 more. That would be 20 out of 50, which is the same thing as 2/5, just smaller pieces. And multiply this by 10/10. That would be 30 out of 50, still the same amount as 3/5. But what's in between 20/50ths and 30/50ths? Well, you got 21/50ths, 22/50ths, 23/50ths, and so forth. So there are infinite fractions in between 2/5 and 3/5. So we can use equivalent fractions to figure out numbers in between fractions.